Hi, everybody. Welcome. Good to be back. Glad to see everybody here. My name is Marco Morales, and I'm a Partner Solutions Architect at Snyk. And what that means is I work with partners. Atlassian is one of our great partners. I enjoy working with them. A lot of great stuff. And it's exciting for us and them here in this conference. I'd like to introduce Eric Smalling.
Hi, everybody. My name is Eric Smalling. I am a developer advocate at Snyk. I've been there for about a year and a half. I have a developer background. I'm in marketing, but I'm not really in marketing. So.
Okay. We'll add in some comments here and there as we describe what we're talking, because there's some good tie-ins to some of the things that we've been intending to say, as well as some of the things that we've heard during this conference we'll weave into the conversation. So today we have a plan. We're going to, of course, introduce the topic and walk through it. Give you some examples around security, and then we'll wrap it up and open the floor up for some Q&A. So today's goal, right? We're gonna take a journey, and this journey is going to be about application security, and we're going to show you real examples to hopefully identify that security is not a hard thing. It's not scary. It's stuff you can do. It's not prescriptive in that you have to do everything. It's rather prescriptive in that we'd like you to look at the different examples and figure out where does it fit into how you and your team work. So sit back, relax, and at the end ask your questions and see what we do. So the context, we're going to use Log4j, which was in December. Most people here have already heard it. We're not going to specifically talk about it, but it is a good reminder, and in the last day of the conference, I've heard people ask questions around, oh, it was a wake-up call, et cetera. So it's good context for this discussion. In the movies, when we have something like Log4j and Log4Shell, the idea that I can run any application or any code is really scary. And in the movies, we have things, and for those of you, I may give like $1 prize or something if you know that picture, but things happen like the bad guys, they launch missiles, they release viruses, or in this case, they destroy an alien spaceship. This happens to be from Independence Day. In the real world, that doesn't happen as much. We get other things like data breaches, people steal or lose data, or they run unwanted applications like I'm going to mine Bitcoin is the popular example. So now we have this, I know what's the danger of having someone run code in my environment. So the common problems that we see and misconceptions are, we've talked about this at length. And one of the ones that comes up, including here, is this perception that security is hard. But the digging into it reveals that what people are identifying is it requires either too much time or work, or there are too many tools in the environment. And that's a big signal because people are already overloaded, and we want to help avoid that kind of problem. But yes, it is hard, especially when you look at it in traditional sense. Tool confusion is really closely tied to that. I hear, and you hear people say, well, I use a certain tool, and they already give me the security I want. Or my team already has a firewall. Why would I need to protect my application? Also, you have vendors out there that will try to tell you our one tool solves the universe. That's not really true. And when you do get these solutions in place, you get a lot of things like false outcomes, right? And people will use terms like false positives, false negatives. Really what's happening is you receive outputs and you believe them, but they're not true because someone made a mistake in the way they wrote those rules. And the last one, which is something that I've seen for better part of a decade in building and delivering CI/CD pipelines, is a perception that the community or the people just don't care. And that's not really true. Almost all developers that I've encountered really do want to have secure software. They just don't have the tools or the knowledge or the capability to do it. So we're going to help you out a little bit in this situation. We're going to go through 3 use cases. I'll cover the first one around applications. Eric will describe things about containers and also infrastructure. So let's just jump into the applications. So vulnerable applications. This is the things that you and your teams write with code and may use some open source. Your teams are highly motivated to write great code, and they may introduce vulnerabilities. That second sentence is important because over time, especially when I've written like these CI/CD pipelines for my customers, people will say, the developer made a mistake or they created an error. It's like, well, they didn't do it on purpose. It just happens to be because people really do try. They try really well. And one of the examples I'll show is It's going to look like regular code, but it happens to have a vulnerability. So let's start saying, things happen. It's not done on purpose. Open source is another one that's really important and popular, especially in modern application stacks. I learned about this number just in the last year. I did not realize that if you were to ask me, I would have thought maybe half the code that people ship to a running environment is open source. For those companies that use it, the payload is actually 80 to 90% if you're running those kinds of stacks. And that's really big. And what this means is most teams may not know what's under the hood. They know I'm using this thing, and it happens to be called Log4j, but they may not know what extra baggage or things. And that's something that's really important for you and your team to understand. And we'll have an example or two. The other ones are on habits. I'll describe an example how, when people were trying to fix this, the habits they had did not yet prepare them for how to redeploy or redeliver this application, which may have been dormant for over a year. So applications, source code. One of the things, and I like this because today we have a member on our team, DevRel, that is part of the OWASP Foundation. I think they're a board member.
A chair?
Yeah, chair. And in my previous company, one of our leaders was also an OWASP. And this is a community, it's kind of like an open source group, but it's a really good reference for you and your folks. And I encourage you, even challenge you, if you have not yet visited the site, go check it out. Because many vendors and many software teams use the OWASP Top 10 as a reference point. So what happens in a booth or whatever, in a POC and pilot, people will say, how do you do against the OWASP Top 10? So everybody knows they have to opt into that model. And that's really good for everybody because it creates common language. There are examples there that I would encourage you to check out and just get a little bit familiar, because the examples will be maybe in Java and other languages, but they'll show you these are typical vulnerabilities, and here are ways for you to fix it. The foundation also has tooling available, which is free for you to use, so you can probably use it in your environment. So check it out. It's well worth the time, even for 1 or 2 hours, in your otherwise busy schedule. This next example is an actual snippet of code that I lifted from the site. And this is the part where I would say, code formatting and indentation aside. I know people have passions about that. If we look at this, we would say, I understand why a person might write a statement like this in Java to insert the value that they ask from a web page, the request parameter. And we would think of this as, and not really think, there's anything wrong with this. It is the nature of that middle part that's highlighted in purple that creates the vulnerability. Earlier, I had the XKCD cartoon, and if you haven't seen it, check it out. But the whole idea there for SQL injections, and Bobby Tables is the name of that cartoon, is that if you don't protect against your inputs, sanitize your inputs, you will have something like this. And what happens is, as an attacker, we'll just try. People expect me to type in a username and password, but if I create clever text in the form of an encoded string or something, I can get control of more details, and then I have an inlet into your system. This statement here, again, looks really nice, but it's not the way to do it, and there's a lot of guidance for how to fix that. So check out the OWASP and really think about how it affects you and your team, because it's a set of behaviors. The next one is attack your software. And sometimes it means you have people on your staff or in contractors doing things like penetration tests or pen tests or whatever you call it. Sometimes they have color teams, red, green, and all those things. But the idea is the more your team behaves like a hostile person or attacker, the better off you're probably going to be. You can also scan and test. But some of the things that we've seen in the engagements over the years is people say, well, I ran my unit test. I added my last name. I used a number. We asked, well, did you do anything to the tech? I'm like, no, because that's not what we do. And like, well, why don't you add some bad payload? And then that opens up their eyes and say, oh, wow, we've always been testing along the dimensions we think that good people are going to enter data. We have not thought about bad data or attack data. So go ahead and do it. And if you don't, the punchline at the bottom is really important. If you don't do it, someone else is. So you might as well get the drop on them. Open source. It's a reality. And let's now consider the context of Log4j. Again, it's not about that. It is a 0-day vulnerability. And what happens? That means that vulnerability was live the moment it launched. People didn't know it. People started wondering over the course of a few years, is this something that can happen? And the answer is yes, it can. So it was vulnerable from the minute it launched and was deployed, and it allowed external people, including you and attackers, to run arbitrary code. Some people call remote code execution arbitrary code, whatever. But the point is, someone who is attacking your system can create a script, insert Java, or some other type of code on your environment. And here's something that's interesting. The attackers don't just say, oh, we've discovered something, let me start trying to figure out how to use this. They already have their techniques, their scripts, their patterns, whatever you want to call it, for how they want to attack a system. They may have a library. They may have a bunch of files already ready. And they're just waiting for the next opportunity to get into your system. So the moment they say, wow, I can really write a file on that system, they're going to do it. So 0 day means within a minute or two, someone can start running code on your environment. The dependency is how it came in. Most people use log4shell because they wanted to log data. Some people, and we saw this on the internet and other blog posts, is they said, well, I don't do any logging, but I learned that the software that I'm using as a third-party library happens to use log4j, and that brought in the vulnerability. And so now everybody is vulnerable. So it's important to understand your dependencies or indirect or transitive dependencies can also bring this. And tooling exists out there to help you with that. And what we've learned, if you've paid attention to the different sources, is that everybody seemed to have been using log4j. The other thing is it came up because it was everywhere, is how does my team patch and deliver updates to code? Most people are used to a CI/CD, it's running just nice, but then they get caught by surprise and they have to go back in time to a project they may not have built in a couple of weeks, months, or maybe a year or two, and they forgot. Maybe something's not working with their build system. It was a reminder. Sometimes you have to be on top of legacy applications, legacy to you, for how to run it. Or if your team is not yet in the mode of, I need to do an emergency patch for my existing live software, it was a good reminder. We saw tons of examples. And at Snyk, we're working with a bunch of customers, and they had a lot of great support tickets saying, my team is now working at 11 p.m. at night. We have to rebuild. Can you help us out with a certain type of problem? And our answer, of course, has to be yes. But it did remind everyone, get used to rebuilding your software. And the other part with the iteration is, maybe it's a bad joke is, well, when they have the patch is going to need a patch. And that was true with log4j, right? The first version came out, oh, it's great, but it's not as great. Let's repatch it and repatch it. And that made the problem more interesting because the people who were already tired trying to figure out how to do the emergency builds had to rebuild yet again for a new version number and so on. How do you be prepared? It's not just a Boy Scout model, but you just got to be prepared. We can tell you about the builds and the vulnerabilities, but really some things we're not going to know what's going to happen. So you won't know until you know, so you kind of have to just be prepared and be on your A game in general. We, of course, saw many examples from our perspective at Snyk and in the industry that some people didn't automate their builds yet, and it's a great reminder, right? And the other one is, monitor your repositories. The revisiting of how good is my repository did come up, and that's something that we would encourage you to do. Let's see, there. So habits. So I put this page here for tracking you and I. We're going to look at this from the same way. So this CI/CD pipeline is representative. Yours may look different, but perhaps together we can agree, yes, it has the same shape and idea of stages. My team writes code, they commit it, it gets built, and at some point it gets deployed. You may have a whole bunch of X runs for testing or some other things, but if we can start looking at this, then we can start using common language. The different tooling, which of course is Atlassian tooling kind of inserted in there, is a call to some of the things your teams might use. Of course, people may have more than one type of IDE or repo, but for the sake of discussion here is we know this is the shape of what people do. And what we would want you to do is, look at your habits and let's review them. And that's what the next couple of points are going to be about. So in pre-commit, back in the day we used to have pre-commit hooks. We talk about either you can have hooks like that or you can have pre-commit behaviors. One of them includes, as a developer, am I doing things like adding extensions, which we hope you would, to do sanity checks for code quality and so on for your code, including security. There's lots of great options out there. We encourage you to do those. The other ones is, and this is going to come up later on with the CI/CD, is I would recommend that you really try to figure out how to work with your teams to encourage developers to build in things like scans into their daily activities. Many developers are highly incentivized because they don't want to waste their time. They're incentivized to not to do security scans because that takes an extra 30, 40, 50 seconds, and they don't want to do this. Somehow figure out how to do it with your team and say, look, let's just come to an agreement so that you are running the scans, you are looking at the IDE extension that gives you this nice red icon telling you probably have a vulnerability here, and make that as part of their pre-commit activities. So that when they do commit the code, and your team is accustomed to doing things like pull requests, many people aren't yet into that mode. If you can, do your pull requests and do things like scan your code. People will say, well, why am I doing scans or activities in both pre-commit and commit? Is your development team may have an environment that doesn't exactly match your common environment, your repo environment. And your development team may not be committing all their files and all their changes or all their versions to the repo. So there is value in you having developers and the repo doing these different operations. Once your code's in the repo, you know what's going to happen next is you have a CI/CD build. The reason we mention scanning again or things like that is that the rendering of your code objects, maybe you're building a jar or putting together a package, or in the other cases like building a container image, those things are rendered objects and they deserve their own type of special attention. This comes back to this point where people say, I already have a tool that does something at the CLI or at the repo. Why would I need something downstream? It's because your code has changed, right? You've brought new libraries, you've smashed binaries and so on. It's worth to you and your company to really embrace those kinds of patterns to do the things. And the other one, the pipeline gates, is one that it's like a dirty thing in the industry, right? Oh, you know what? Why don't we just do for like the Maven folks? Let's just do skip test equals true, right? And you move on and you know that you have 500 errors or unit tests that don't work, but hey, at least we ship code. Try to figure out with your team, encourage them. We've seen people start at the lowest numbers and start increasing severities or whatever things, but start using your gates to fail that build if your team doesn't have running unit tests or security scans and so on. That's all I can say about that. And in your production environments, there's many metaphors, chicken and the fox in the henhouse and things. It's also important. Like, I've done all these things. You do have to monitor your production environment. We'll use in contemporary language the example of Kubernetes. There's a bunch of monitoring options available so that you can pay attention to how is my workload in my cluster behaving, CPU, ports, and so on, and logs, et cetera. We encourage you to do that. Lastly is Snyk, as a great partner of Atlassian, we love them a lot. We put together a cheat sheet and we co-branded it. That's the URL. This presentation will be available, but the little image is here. And it's some of the things that we call out. If you use Atlassian Bitbucket pipelines, here are some of the things that we would encourage you to do. Tons of links on this, this asset that reference external tools, open source projects, and other behaviors. We would encourage you to try those things out. If I'm right at this point, it's now Eric's turn. I hand the clicker over to him.
Thanks, Marco. So Marco had the hard job of talking very broadly because there's lots of languages he had to talk about and lots of CI platforms and everything else. Of course, everyone here uses Bitbucket, but if you don't, you can understand there's a lot of things there. I'm going to get into the nitty-gritty about containers. My background is containers. I worked at Docker for a couple of years. I've been using containers since 2013. When it was like .7 version, before we had orchestrators, before we had Compose. So I'm going to get a little bit more into the weeds on this, hopefully. And when you talk security around containers, especially from a developer's point of view, it's a whole new world for a lot of developers because you're dealing with operating system concerns like with distributions, file system permissions, things that middleware teams or sysadmins have done for you before. Now, you still have their input, but you are responsible for not screwing it up. You've got a Docker file, you've got Kubernetes manifests, you've got whatever it is, and you need to make sure you're not introducing problems. And the three areas I'm going to touch on related to containers specifically are what's in your container, what's the architecture of it, how it's getting built, some of the tools and strategies around it, and then supply chain is a huge topic, but I'm going to touch on it as best I can in the limited time we have. They didn't start our timer, so I got all day. So first, let's talk about the images themselves. So every image you build, 99% of the images you build are going to have some kind of base image, and that is your starting point. You need to pick the right base image for what you're doing. This example I'm showing is if, let's say, you're a Python shop and you are Python 3, you can use Python tag 3. This is the official open source Python image from the Python and Docker folks. This is fine. However, you don't really know what minor build or patch build that this is based on. This can be great on a developer workstation if you're just iteratively building images and want to always have the latest thing. Or if you're in a CD shop that deploys multiple times a day, maybe you do want to use this kind of thing. But usually, most enterprise developers, you really need to have reproducible builds, and you need to know what version of the base you're going to be, predictably what you're going to be on. You can use 3.10, also good, but that is also a moving tag, just like 3 is. It's going to always be the latest 3.10 build. So it's always best to choose, in this case we're using semver, so 3.10.2. You can even get more verbose and use the full-on SHA hash. That gets a little brittle and it's a little less friendly. So at least use something, unless you want to do latest all the time, use the most specific so that you can predict and know what image is going to get used by your CI systems when it builds it. Now, on top of that, there are many flavors of these tags. And if you look at Docker Hub and you go into the tag lists on some of these open source images, there's hundreds of tags. In the case of Python, at least on the day that I did this slide, the main 3.10.2, what I call the general image, was nearly 1 gigabyte in size. And developers love these images because we don't have to worry about any other packages. I can start up and I can build from Python and I've got everything I need. Unfortunately, if I deploy an image to production with that, my hacker friends out there have every tool they need probably in that image. They've got curl, they've got wget, they've got all sorts of stuff that if they were able to use well, Python's a bad example for log4shell, but an RCE in Python, say if you're using Celery, there was one of those earlier this year. They have those tools available to them when they do that remote code execution to leverage. There are a lot of images have what is called a slim tag. And what has happened here is that the teams in this case, the Python team, has worked on making a version that only has just the packages you need for running a Python 3 app. It doesn't have a lot of the extra stuff. And you can see in the sizing that drops it a lot. Now, the other set of images a lot of people, and I am a fan of, are the Alpine-based images. Alpine is a distribution of Linux that is security focused and it is made for very small footprint. It's based on BusyBox, if you're familiar with that. And you can see it's tiny. The only problem, I call it problem, only challenge with an Alpine image is if you are dealing with any kind of compiled binaries that you call out to include, say you're a Java shop and you're doing a JNI call, it uses muscle C, not glibc. So you need to make sure that you're not going to that and then breaking everything else because it can't run with that compiler. If you're doing that, you might also take a look at the distro list packages from the Google folks. These are hyper small. The sizing is very similar to the Alpine one here, but this is a Debian-based image, so you don't have to worry about that compiler difference. And the distro list images have they're the most minimal I've seen out there amongst the supported images. They have Python, and that's it. There's no shell included in them. There's no package manager included in them. It's just the bare minimums. And they have several of these for Java and Go and other things. The challenge with using something like the distro list is that you now have to, if you do need an extra package, you have to get it yourself. You have to compile it, copy it, and do whatever you need to do, and you're kind of turning into a sysadmin at that point. We'll see some examples of these in a second. Also, when you're talking about architecture, you need to consider how our image is made. You need to have an understanding of layers. And I don't have time today to go through a full Docker 101, but just understand that every image is made up of a bunch of layers that pile on top of each other, and then when the container runs on top of it, it's presented with a unified file system based on that. And there are some techniques, we'll see an example here, for making sure that those layers don't contain anything you don't want them to contain. And you also want to make sure you specify versions on packages and whatnot. Let's look at an example. So this is a Ruby example, just to mix it up a bit. And you can see at the very top, you try the laser here. Hey, there we go. So that's, I love this, it's a green laser, it's great. I won't shoot you guys, trust me. So this is a semver specific 2.7.0 Ruby build, so that's good. It's not going to have, you know what's going to get built when you build this image. However, it is a general one, so it does have the kitchen sink in it. Keep that in mind.
Second thing I'll show you is this run line. What we see here is a compound command. So the run line, if you're not familiar with Docker files, this is what builds one of those layers. At the end of the line, whatever the file system state is in, that's what will get put into that layer. Think of it like a git commit. When you add and then commit into a git repository, that commit contains the delta between what was there before and what you wanted to be in that commit. By adding this all in one line, you're doing the update to get your app caches, you're doing the install of the tool. In this case, we needed the SQL 3 drivers and stuff for this Rails app. And then you're removing all of those caches at the end so that you're not including a bunch of extra junk in this image. You got the junk you already up here, you don't want more of it here. And then we go through and we do other things and we build our Rails app and we run. So again, this one, because it's based on the general image, it's going to have a lot of things. And if there is a remote code execution possibility, that hacker is going to have a lot of tools at their disposal. So let's take a look at what it would look like with a slim tag. Here, we have a whole bunch of atkits. In fact, the projector is cutting off the top. This, if you could see that, it would say Ruby 2.7.0 Slim Buster, which happens to be the one I picked for this example. In this case, the development team would have had to go through and figure out all the different packages that they used to get from the general image and put them all in there. I don't know why, when the people I work with, what they think they need Vim in their production image, but I'll have to have a talk with them. They also, anyway, so you're now having to manage this. You are the sysadmin for this machine, even though it's not a machine. But these are all compile time dependencies and runtime dependencies. And the rest of it looks very similar. So it would be nice if we had a happy medium between the two of these. This is where a tool called Multistage builds comes in. Docker added this in 2017. Almost all Docker file-based build systems will support this now. And this allows you to have multiple stages, which are delineated by their different from statements. The final one is the one that actually gets saved, pushed to your registry, and shipped out. To see an example of this, you see this is very similar to before. We have the general top level from, and I've got a tag on it. We're calling it build environment. Basically the same thing we saw in the first example, and then I have another from down here where we've got the Slim Buster. So now we're kind of seeing the other side of it. But because the build is what needed all those extra libraries, the only thing I'm having to do is get that same SQLite 3 drivers and everything. And then when I'm done with that, the second stage sets up some variables just to make things easier to read. But all I need to do is get that database driver only added to my image, and then this copy line is saying, hey, from the build environment tag, which was the stage at the top, copy the Rails app and the gems that I needed for this build and deploy that. This image will be much smaller because it starts from a slim image, and I am only adding back in the things I need for this image. So take a look at multi-stage builds. There are also there are other build tools you can look at. So if you are building in a CI environment in Kubernetes, Kaneko is a very popular tool. It's a great from a security standpoint because it doesn't need the Docker or CRI or any container runtime engine to build the image. In the old days, I used to be a Jenkins ambassador. We used to do a lot of Jenkins work. We would do, mount the Docker sock into your agent, and don't worry about the fact that you're now basically root on the box from your build scripts. Well, you should worry about that. Kaneko is a great tool. It doesn't require any container runtime engine. Neither do any of these tools, actually. Jib is great if you're a Java shop. Take a look at Jib. It builds container images just from the JVM. It doesn't even need any extra tooling. Oops, I hit the button early. There we go. If you're a Go shop, Co is probably, you're familiar with it. It's a similar type of a tool. If you're an OpenShift shop, you're probably already using Builda. This is the Podman Builda pairing. For building images for, if you're on CentOS and Red Hat, you're probably doing that. And then Kpack, this, I actually don't know a lot about Kpack. This is the Tanzu folks. If you're using Tanzu Community or Tanzu Kubernetes, you might have seen this, talked about that. This is something I believe was kind of based on some of the pivotal work around build packs. Take a look at it. It's kind of interesting. I haven't had a lot of time to research it, but finally, supply chain. There are entire conferences around supply chain right now, so I'm not going to give you the full spiel, but the basics are you need to know where your base images come from. Don't trust that I'm getting them from the internet as part of my CI system. You should have a local proxied cache in your own registry that you have vetted to make sure you know where it came from, and that it's you're not getting injected with some bad one. You want to make sure that you are using a secure managed artifact repository. such as, you fill in the blank, all the different registries out there, whether it be the open source Harbor or ECR if you're in the cloud, or a paid Docker Hub account, whatever. Make sure that you trust the registry that you're connecting to. And never, never, never deploy the image that Eric Smalling built on his laptop to a server anywhere, because you have no audit control. You have no idea what I put into that image. Audit, audit, audit. You want to be able to audit everything. Speaking of audit, one of the big emerging technologies that as soon as I say something about this, it's going to change. But take a look at the work that's going into software bill of materials. The two kind of most popular standards of these are like ingredients lists, or what are in a artifact, which is a very generic term, but we'll say an image if we're talking about containers. CycloneDX comes out of the OWASP world, and SPIDX is Google's standard. Both of them are, I would say, equally popular. I think anecdotally CycloneDX is kind of more popular in the enterprise space at the moment. But both of them are worth looking into. They're a way of saying, here is what is in this artifact, and you can sign it and make sure that you store it along with your images. And anyway, again, we don't have time to go into all the details. Speaking of signing, there's two major projects right now that are getting a lot of press. The SigStore team has cosign and some of the other tools around it for signing artifacts and storing those in an image repository like an OCI compliant spec. And the Docker team that invented Notary, both of these are CNCF projects. That is useful if you're using Docker Content Trust to make sure runtimes only are running signed images. They just released V2, I don't want to say a year ago, but recently. So you can take a look at that. And then finally, there is this neat project from the Google folks called SALSA. I'm going to have to read this because it's Supply Chain Levels for Software Artifacts, which is a backronym if I've ever heard it, because they just wanted to call it SALSA. If you go to salsa.dev, you will see a page, and it really basically what this is it's a common set of terminology and levels to say my organization or my project is secure in these ways. And they have level 1 through 4. They missed an opportunity to not call that mild, medium, hot, and fire because it's salsa, but that's, whatever. So we've talked about containers. We've talked about building your images, making sure your teams are doing that well. Let's talk about the runtime. And if you're talking runtime and containers in 2022, you're probably talking Kubernetes. There are things to keep in mind here. The heavy hitters in this area are making sure your resources are set up for limiting your pods and containers, making sure your pods themselves and the containers are being limited in what they can do through security contexts. The network policy piece I'll touch on, and then how do you enforce all of this. So first of all, processes. Containers are just processes. There's nothing magic about it. It's just leveraging tools in the Linux kernel, and I guess in the Windows kernel if you're using Windows containers, to limit the resource, to encapsulate things, kind of, sort of. But one of the things is resources, CPU, memory, network, whatever. The resource requests aspect of a Kubernetes deployment is basically telling the scheduler, this pod, or this container, this process is going to need this much resource to start. Please don't schedule it to a node that doesn't have that much. That's interesting and cool, but the really important one, in my opinion, that's important, but from a security point, is the limits. Limits sets what they call the C groups, which says, hey, this process can only use this much resource. For instance, if you say it only can use 1 megabyte, because it's a little tiny microservice, if it tries to allocate 1 more byte, it will get an out-of-memory message from the kernel. This will stop an attacker that say they have log4shell, and they get on your box with their own thing, and they pull down and start trying to do crypto mining. And as soon as it tries to do that and takes up more memory, it kills it. It's not stopping that hacker, but it's making life hard on them. So you don't want somebody getting on into your container and start doing things that are going to push all of your other workloads on that node out. By setting a limit, it kind of puts a box around, a sandbox-ish kind of a thing around that process. Same thing with CPU limits. Basically, they'll only get enough cycles as what you say it's going to need. So again, like a crypto miner can't take over your entire CPU and kill all the other processes by doing it. A lot of denial of service type of things can happen if you don't set resource limits. And then, yeah, so let's talk about security context. This is kind of my baby lately because it seems like I end up talking about it everywhere. There's several things you can do that make life hard on a hacker. So for log4shell, for instance, or even Spring4Shell, which I hate that acronym, but the Spring Boot one that just came out. Any RCE, if they get into your box, they're going to be whatever user that process was running in. And even if you're in a container, if you are root, you are UID 0. And if they can get out of that container, they're UID 0 on the host, on the node. If you have mounted a file system from the host, which you should never do, in my opinion, if they mount it, though, they're UID 0 in that file system. Now, there are mitigations for this. There's user namespaces and things. But generally, for most business applications, there is very little, if not no reason to be running in your container as root. And you can enforce that in your Kubernetes deployments through the security context run as non-root true. When the kubelet sees that, it will not start that container with the UID 0. You can also specify specific user and group IDs. In this case, I'm using the user ID from the Tomcat official image. There's a nobody user that Tomcat can run as that has basically execute and read writes inside the container, but it can't do much writing anywhere that is important. It can do what it needs to, but you're not going to be able to overwrite the WAR file. You're not going to be able to do a lot of things. So it makes life harder for the hacker to then modify things on the file system. Speaking of file system, come on, clicker. It's going to go like 5 slides now. Containers by default will start with a read-write layer at the top where all mutations to the file system happen. If you specify this, which is the same as on a Docker run line that's doing --read only, it won't put that read-write layer down, and you effectively have an immutable root file system. Doesn't impact mounted file systems, but at least for the root container file system, it's read-only. And again, this makes life harder for a hacker to do things. If I get log4shell going and I get a remote code execution on there and I'm going to go curl down my crypto mining script, where am I going to put it? Maybe I could put it in temp. I have to go start poking around. It's not an easy, low-hanging fruit anymore. Plus, immutable containers are good. It's one of the 12 factors. Make your containers immutable so that they can be rescheduled around anyway. Next, Linux capabilities. Again, business applications often do not need these. These are parts, basically these limit what system calls your process can make on the Linux kernel. For instance, ping needs netcap add because it has to be able to manipulate the ICMP and the stack to create these things. Your business application probably doesn't need to be manipulating the network stack. I am a fan of dropping all Linux capabilities and then finding out if your app won't run with it using tools like Falco or Tracy or figuring out what it is you need to do that. There's tons of blogs on how to figure out what capabilities you need if this doesn't work. I don't want to give out any vendor specifics, but Google that and you'll find a bunch of stuff. But try dropping them all. It will probably work in your business applications. Privileged, never use privileged. Done. This basically gives you access to the devices on the host. It's like being root on the box. Unless you're running low-level monitoring software, writing network plugins, if you're doing, again, any kind of business applications, you don't need privilege. The thing that it is default false. I like to be pedantic and include it. And I'm watching the clock here. Privilege escalation is not defaulted to false. This is if I get on your box and I can curl down something that has SUID bit set, I can become root on your box. By setting that to false, it limits that. It makes that very much harder to do because it will not allow you to elevate your privilege. So you've set your user to nobody, and now you're trying to sudo through whatever file I brought in. That will stop that. We have a cheat sheet on this. There's a URL at the bottom that'll take you to it. This goes over the 10 most commonly used container security context APIs and how to use them. And I'm really running out of time, so I'm going to rip through a few of these here. Network policies is a huge topic, but and a lot of developers like myself, when I first saw it, were like, oh my gosh, firewalls, I don't know what to do with this. Actually, it's not that complicated. It is just limiting what pods can talk to each other. I'm a fan of the deny-all style pattern, where you say nothing can talk to anything except for what I add to the allow list. And this is an example of a policy that says, pod selector wildcard, all pods in whatever namespace I deploy this, cannot egress to anything but DNS. And this is overly broad, probably even for my taste. But this would have stopped, it would have minimized the blast radius of log4shell by having this on your clusters. Even if they got past your WAFs or whatever else, they would not have been able to get out to an LDAP server to get that JNDI payload, if you're familiar with how that thing worked, because they would have been blocked. So it's not, again, it's not a silver bullet, but it's a great mitigation to limit those blast radiuses. I recommend taking a look at Amit's, this GitHub repository has great recipes that show, I don't have time to go through it right now, but he's got animated GIFs on there that show traffic in and out and how to apply things and what the policies look like for that. Again, these slides will be made available to you. And finally, everything I've talked about can be enforced at deploy time with admission controllers and policy enforcement tools like Kyverno or OPA with Gatekeeper and other tools. I'm out of time, so come on. Wrap it up, Marco.
Thank you very much. These slides will be available. You know, there's a lot of rah-rah. Just go and do it. Thank you for this.